Hello, my name is Thomas Locke, and I am a chemistry BA major here at UNC Chapel Hill. I'm a junior in the graduating class of 2027, and some things that I love to do is I really enjoy playing basketball and enjoy de-stressing by playing the guitar in my room. I want to be a chemistry ULA because I know it will help me to understand chemistry better and to be a more well-rounded chemist in general. I also know that in my past, I've had fantastic ULAs that have really helped me to understand chemistry better, and I would really enjoy to be that person for somebody taking these classes. I will help students to develop better study habits by letting them know what I've done in the past that has really helped me, and to also urge them and give them advice on how to do active study habits such as practice problems, which has really helped me in the past. Okay, so there was a student that came up to me, they raised their hand and they asked me this question about this complex here. They were told to draw it, determine whether it was high or low spin, the d electron count, and if there was Jahn-Teller distortion. So we're gonna work through that together. So we have a rhenium complex right here, and what I would tell the student is that because we have 6 carbonyls right here, we know that this is going to be an octahedral complex. So we'll always start with the metal center in the middle. And the best way to draw an octahedral complex in 3D stereochem is to include the stereochem here, which is typical to the teaching that we have been learning. Around this, we're going to include the carbonyl groups. And we know that the bonds between the carbon and the oxygen are triple bonds. So we're going to add triple bonds here. We also know that it has a counter ion. So this is going to have a charge. Chlorine typically has a -1 charge. So we know that this will counteract that and have a positive charge, and we'll throw the chlorine out here. So now we have to determine whether this is high or low spin. This flowchart, which was provided to us during class, shows that because rhenium is in the 3rd row of the D block, it will be low spin. For the d electron count, this is a little trickier. Here we know that this is going to have a +1 charge and this is going to have a negative charge. Because of this, we know that the formula is going to be oxidation state minus X-type ligands equals D count. So we know that, excuse me, I was wrong there. Will equal charge. So we know the charge here is going to be +1. And we can look at our X-type ligands. Here we see that there are no X-type ligands. This group will be an L-type ligand. So we will say 0. And so that we know the oxidation state of rhenium will be 1. So we know that it will be rhenium 1. Now that we know rhenium 1, we can look to see what group rhenium falls in on the periodic table, and it falls in group 7. So to find the d electron count, we do group number minus oxidation state equals d count. We know the group number is 7. We know the oxidation state is 1, so our d count is 6. And we will label this as D6.